If you don't know me, I've been to a few meetings before, but I'm quite new to EVs. I started showing up late last year because I work for a Finnish-based maker of underground mining machinery. And we are developing machines in Australia now for the mining market. And one of the interesting things I found a couple of years ago when we were looking at developing machines was we started comparing what everyone always does, which is diesel vehicles and conventional drivetrains, with EVs. And what I've found is probably something that all of you in the room are all familiar with, which is EVs are better cars to drive, more pleasant to be in, more economical to own, more reliable, just all round a much more pleasurable vehicle to own, operate and have in your carport than any petrol or diesel vehicle you've ever owned before. And once you buy one, you're unlikely to ever go back. But very few people are aware of that, and certainly in industrial applications, no one's aware of that. Regardless, we're decided at Normet that we're going to persevere and build the thing that does not exist yet to try to demonstrate to the industry that they've been stuck on the wrong track for too long and that they should actually be exploring this type of technology because it'll give them a fundamentally different operating environment in mines. Okay, so who's Normet? I'm the engineering manager for the Asia Pacific region. Normet's a niche Finnish maker of mining trucks. They've been making vehicles for 50 years. They're a really respected brand, but because they're underground, no one knows who we are, unlike big yellow caterpillars. Okay, but in that time we've delivered 10,000 machines and every single one of them's got a diesel engine in it. Okay, we're in 1 or 2 locations, and the interesting thing for us, we're diversified across across chemicals, construction. About half of our business is vehicles, machinery, and a third of our business is in the Asia Pacific region, which is why it becomes relevant to us, because the single biggest market for cars and the single biggest growth market is on our doorstep. The Australian office is responsible for developing small vehicles, and we've got the greatest opportunity to be able to develop a vehicle which we can sell to Asia from Australia in this new emerging market. Okay, so where are we? The first thing was to develop a vehicle that works, and we just stuck with what we know. So we've got a vehicle which has a diesel engine in it. I'm just finishing off in our workshop in the next couple of weeks, and we'll be testing that vehicle. But this is what we're starting with, is to turn our existing vehicle into a battery electric vehicle. It's really designed to replace Land Cruisers that are used in mines now, and I'll explain why Land Cruisers are probably not the best thing in a minute. I'll show you some pictures that make it very, very clear. It does what, in a mine, you've got big burly blokes with big burly tools carrying big heavy things around in terrible conditions. So it's got to be a big, heavy, burly, indestructible type of vehicle, and that's exactly what we've made. It's big, it's simple, you can run it into stuff and bash it around. It's not designed for going on highway. We'll never get this on the surface. So if we commercialise this in South Australia, you'll still never see these things. That's okay. So what we're going to do first off is we realise how mines work is that they'll work from smoko to lunch and lunch to afternoon snacks to knock off, right? So in an EV we need to have something like a 3-hour drive window for the vehicle charge, and so you need quite a lot of power for that, and it's quite a heavy vehicle. And it's got quite a heavy load capacity, but the thing with EVs is that they go slow very, very well and draw very little power. When aerodynamics is not a problem, they will just go and go and go. And the torque of the motors is such that they like going slow because they're just as efficient going slow as they are going fast. Okay, so why aren't Land Cruisers any good? Well, this is a Land Cruiser in a mine, and it looks kind of okay like that, but that's the sill panel and that's the door, and I think there's quite a few parts falling off of that, and that vehicle's only a couple of years old. Okay, and there's an entire yard full of hundreds and hundreds of these, and these are all Land Cruisers, and they're all about 2 years old, and these are the ones that have been used to the point of economic destruction. They simply cannot get these things to run anymore, and they're 2-year-old cars. And when you take the body off, that's what it looks like underneath, and that is a 2-year-old car, and it's never been in the ocean or near a boat ramp. That's just what happens. Okay. And how many of you guys have been in mining or been underground in a mine? A few, yes, you're pretty familiar with the kind of environment, but for those that aren't,
So what's
just put up a bit of a video for a couple of minutes with some very loud sound. That's what you see. It's dark. It's not very good. Sure. Okay. So you're in a mine, it's dark, it's wet, you can't see where you're going. The road conditions, even though you can't see them, aren't very good, and you're constantly just following other big, heavy, horrible things around, blowing dust and rubbish all over you. It's great conditions to work in. It's fun. I like being a miner. But it's not quite the same as working in an office. And so for the vehicles, it does tend to really destroy them. And because of those conditions, you've got no access to water, you can't wash anything, you can't clean anything. And yeah, so the equipment just really degrades really badly. But on the flip side, for an EV, this is all you're doing all day. You're following some other vehicle that's bigger and heavier and slower than you at a nice leisurely pace, and at this pace, he's going downhill, and it's a 1 in 7 gradient, so it's like some of the steepest roads around Adelaide. And so we can use regen to store energy, which you just simply can't do with anything else. So all the way down, you're just using regen. One of the things, and as you can see, this is a main haul road. It's a nice road. What they're doing in Newcastle is the same thing as that they do with the buses around metropolitan areas, which is put the wireless charging systems that are embedded in the roadways. They're developing that for mines. So if you have an EV, that main road will have a wireless charge loop buried under the road. As you drive down there, it's not using any battery because it's pulling the power directly off grid. So what they're doing now in industrial applications is that dream position that we all want to be in our EVs in 10 years time, where we're going, gee, I wish the state government had put some wireless charge up the middle of that new freeway we're building, because that way we wouldn't have a problem about whether we would be able to drive to Birdwood on the weekend, because all the way up Northeast Road you would just be running off grid power. So this is where EVs, I think, are going in some scenarios, and we're just looking at actually commercialising that, demonstrating that, using that in South Australia within the next 5 years, not within the next 25. All right, everyone's got a fairly good idea about what mines are, which is you can't see where you're going. And you don't have the stereo on like that either. Okay, Nathan. Okay. Now where we're going with this vehicle is up to Mount Isa as one of the mines we want it. They've got 2,000 kilometres of roadways underground at Mount Isa. 2,000 kilometres. Now, you think what happens when you're driving a fleet of hundreds of vehicles with 1,000 horsepower engines in 2,000 kilometres of tunnels, how much ventilation does that require? That's the same as having an underground tunnel from here to Perth. It's ridiculous. So by putting EVs into that kind of environment, it just makes good economic sense, because the ventilation requirement's no longer there because you don't have exhaust. Okay. All right. Where else are we? Well, we don't have a mining boom anymore. We've got a mining bust, and everyone's going out of business, and everyone wants a way to save money in mines, which is why we're acting now, because mines are now faced with having to make a decision. Do I go out of business next month, or do I buy that EV that I would never have considered before because it's cheaper to own? So ironically, during the mining boom, we would never have got this up because it was business as usual. We're now in this beautiful scenario over the next 5 or 10 years where economics says that people must find a better option, and we're going to present one. Mines are also want to operate 24 hours a day, so by putting EVs on there, we don't actually have a problem with that charging cycle, because with that wireless grid we're talking about, you'll never have to stop to refuel these vehicles. You'll never have to refuel them. That's vastly better than any vehicle you can currently drive. So it's going to be a really interesting exercise for us, because we're going to be developing in South Australia all these kind of dream products that everyone wishes that they would have or be able to try, and hopefully we'll actually commercialise this. Okay. So yeah, this will happen over about the next 12 months. By Christmas we expect to have our first prototype running, and we want to put that out in the field for about another 12 months just to be able to get some user feedback, because it's such a new area. No one else really has this, at least in the Australian market. And what we want to do is commercialise this, because post 2017 there are no car makers. There's no auto industry in Australia. How many people do you know that are working on EVs and there's an auto industry in Australia? There's really very little. And it's a really great opportunity, because currently there are about 1,000 Land Cruisers per year that are sold for underground mining. 1,000 vehicles a year. We don't expect that all of those will become electric, but if it's a vehicle which is cheaper to own, cheaper to run, you'd get a significant proportion of that fleet. That's a massive number. That'd make us the biggest car maker in Australia post 2017.
The only one.
Ridiculous. Okay. That's just domestic market. The overseas market typically is anywhere from 5 to 10 times the size of the Australian market, based on the way Normet sells all of its other equipment. Really big numbers, so hopefully we can actually find a vehicle that will do what we want, which is why, I really like being able to talk to everyone we have in this room here, because it's that collective experience around people that already own EVs, that run them, that is so important to be able to commercialise this and actually make it a successful thing, where we can actually have an EV industry in South Australia. Okay, and we actually have the supplier base. Out of all of the automotive stuff that exists in Australia already, when we look at the vehicle, a really significant proportion of it is actually in the local state or in Victoria or nearby. So the system's already here. It's just a matter of bringing everyone together and actually making a go of it. And we have to hurry too, because what we're seeing overseas is that this is happening overseas. The problem we have is that, at least federally, we're a little bit regressive, a little bit backwards. I really don't see the market potential and opportunities for this. And what's happened overseas is that in places like Canada and the US, they've regulated, to be able to allow EVs into this kind of environment, and that allows people to make cars, and that allows them to take the cars to mines and sell them, and then they have a product. Now, at the moment this is only small companies and they're not a significant global challenge, but it's not very far away before the big boys start to come to the table as well and see exactly the same opportunity that I've got. We know that General Electric is working on EVs for mining and mining applications. So, and for EVs generally, that's a good thing. When General Electric gets behind electric cars, I think that's quite a lot of money. It's much like all of the talk about Apple getting behind electric cars. They're the same kind of oomph, the same kind of commercial power behind it to make it happen.
And Google.
Exactly, and Google cars. When you've got companies like that that say they want to do it, it's going to happen, right? They just have a little bit more inertia, luckily. So what we're relying on at this point is we know that they're investing in this kind of technology, but the development cycles can be longer. Apple's not, unfortunately. They're fast. But yeah, we've got this short window of a couple of years to try to set up this industry in South Australia, and we don't want to lose that chance. State governments are brilliant. Whether the South Australian government, Victorian government, they can understand how the economics of manufacturing work. They really want this to fly, and they can also see just how rapidly the EV market is growing. So they really want to get this up. We're just limited at the moment a little bit federally, that without but there are some regulations, some rules that are national. And without some national standard, it becomes very difficult to develop something, because we end up building a vehicle which is satisfactory for South Australia, but then when I take it across the border, I then have to argue from the beginning again that this vehicle's safe and it's fit to use and it meets all of Victoria's standards, and it's a terrible merry-go-round to be on. Okay, like I said, people already started working on this. The other one that's actually working on this in the industrial area is John Deere. John Deere works on construction equipment, on farm equipment as well, and that's another good thing because they're also a massive company. They don't have batteries at the moment, but what they have seen is some very good quality motor controllers and AC controllers and stuff like that. So there are so many hidden pockets that actually mean that electric vehicles, electric cars are actually going to start to prosper from all of these parallel chains of commercial industry, because I think consumer products, EV cars are consumer products. It relies on a consumer to pull it through to be able to get demand for it, and it's growing rapidly. But for what I do, which is commercial products, it's pure economics that pulls it through. So it doesn't matter whether someone doesn't like the colour of the seats or the shape that it comes in. If it's cheaper to own, if it's a better tool, people will buy a better tool, regardless of perception. So I think there's a lot more that can be done in the commercial field to actually get ahead of where cars are. Okay. Now we also like to look at the rate of growth, and something I find that really interesting in studying EVs is comparing EVs to mobile phones. Motorola invented the mobile phone in the mid-80s. They made a forecast back then that by the year 2000, after 20 years, they would sell 270,000 mobile phones across America. 270,000, they were excited by that. I think the forecast was wrong because, like a lot of people, we see the same thing in EVs. Someone sees EVs and we go, well, we sold 200 EVs in Australia last year, and we sold what? Possibly, I think it's about 380,000 I think we'll sell globally this year in EVs. And one goes, yeah, but they're going to sell 70 million cars. It's not significant, but the rate of growth is the important thing, because mobile phones grew from 1980 up until effectively 2010 at about a 20 to 30% growth rate every year, and EVs grow at the same rate, and that generally means that in not very many years, there's going to be an awful lot of EVs out there. I think if EVs continue to grow at this rate, basically you've got a monopoly somewhere by about 2032. It's not actually that far away. And if you think back to 1990, did you have a mobile phone? Well, I didn't. My parents didn't. My friends didn't. My rich brother had one. But then by 1995, I had a phone and my friends had a phone. And it was fairly normal for young people to have a phone because it was a new young people's thing to have, was a phone. And then by 2000, my parents had a phone, and then by 2010, no one has a landline. Okay? It happens quite quickly. So that's what we're relying on. I work for a Finnish company. The thing that happened in 1990 in Finland is this tyre maker called Nokia looked at emerging markets. They saw all these people with landlines, and they saw this big, bulky Motorola mobile phone and said, that's interesting. I'm not making money making rubber tyres. What if I become an electronics company? And by 1995, 5 years later, we had the standard Nokia phone. And they dominated the market for 15 years until happily Apple came along and superseded them. But in 1990, no one in Nokia would have expected that they would sell 1 billion phones, but that's what happened. Okay. In terms of employment, there's a really good opportunity for us as well, because as I said, the market's really quite significant. We don't expect it to be very fast in the early days, but that's probably a good thing. Each vehicle has about 160 hours in our factory for it, and if you're making 300 vehicles a year, it's quite a significant amount of jobs, and it's quite a significant amount of money coming through the state. And yeah, for mining customers as well, they're saving a lot of money. And generally it's all good for everybody, because if we can actually get the mining, as much as mining can have bad perceptions, it does have a lot of good that comes with it. You know, we have taxes, we have royalties, we have all the materials that come with it. And to be honest, by doing things like this, mines can actually do good things by actually being a pull-through of modern technology. So if we want EVs, if we want lower greenhouse gas emissions, mines actually want that too. And they'll pull this through to actually allow us to set up a manufacturing industry which would never have existed otherwise. And yeah, so it's a really interesting time. The next 12 months is going to be really interesting for us. I'll certainly be annoying people somewhat to try to tap into whatever expertise we have around the state to be able to get this prototype looking good, running well, because the next 12 months really gives us that window of opportunity to build a really nice prototype so that next year, hopefully we can make this commercially successful, get some jobs, and set up a beautiful little industry, a cottage industry in South Australia, which is really unique to the nation.
One point that you made about the Land Cruisers and how they're corroding and falling apart, are you also proposing a different build style? Yeah, okay, sorry.
Yeah, yep.
That first vehicle you showed, the 1.5 tonne one,
Yep.
that you said is one of the Normet vehicles.
Yep.
Why aren't you using those in the mines rather than the Land Cruisers?
Because we've only just, that's a new vehicle we've just developed, so yeah, it's only goes to test in the mines next month.
That's with the diesel engine.
That's with a diesel engine in it, yeah, and then we're looking to spin the electric version of that out over the next 12 months and as quickly as possible supersede the diesel. The diesel just demonstrates the vehicle works, but the EV is where the action really is.
That's opportune at the moment as well, isn't it?
It is, yeah, yep. Yeah, they go together, they're a matched pair.
Did you explore the cost benefit of initially doing a conversion?
Yep, yeah, and it's something that you probably find when you do conversions of your own cars out here too, is that there's a lot invested in the car in the normal diesel petrol systems, which is suboptimum for an EV to begin with. So you spend a lot of money buying that stuff only to rip it out and modify it anyway to try to get something that'll work really, really well. Yeah, I thought about using the Rex, but there's so little of value in a conventional car that there is constraints to how you would do it otherwise. You end up building an EV that's not as good as if you'd actually just started with a blank piece of paper, and it costs you more. So.
How far have you actually got with your development program? Where are you doing it, and how many people, what's your staff, and where's it actually happening?
We've probably got about a staff of 3 or 4. I've got a couple of electrical engineers in Finland, and I've got me, and I'll steal one of my other engineers to secretly help on the side here in Adelaide, but that's all you need.
Well, that all sounds a bit, as you said, cottage industry. Like,
it is.
Sort of a company such as yourself, it's obviously a multinational company.
Yep.
You must have potentially millions of dollars backing you to do this development. I'm wondering why you sort of haven't got a little office down in, or a big office in Tomsley Park with 20 people working on
Yeah.
building 3 or 4 prototypes.
Yeah, and there's I know, it's a really weird thing that I have no idea what people do in those big car offices when they're designing things sometimes, because we've never needed big staff members to push out massive amounts of design work. Like that entire vehicle there, that was done by 2 engineers. It was a complete vehicle.
Yeah, but you need
took 2 engineers. And took 2 years, to be frank.
You need a reasonably educated and trained
staff,
and the people to build it, the actual people that actually do the building are not easy to come by.
No, and that's going to become one of the critical areas for us. Isn't so much the engineering, because like I said, a good smart engineer is as good as 10 not smart engineers. And you can really get a lot done with a small staff, and it really helps to be able to get that off the ground, that we have deliberately kept it very lean, because if we had a staff of 20, the overheads are so high the vehicle becomes really expensive. You know, yeah, yeah, I know, but if I've got a $3 million per year overhead, now we only make, you know, a few $1,000s per car. I need to sell 300 a year just to break even. So if it's not designed deliberately to fit into a small staff, it never goes anywhere. So we realise the economics of it. It's designed to be a cottage. And the other trend that we know works in automotive is that big automotive factories don't work very well. I mean, the best automotive companies in the world make a 15% margin on their cars. They're making 10 million cars a year in a single country and they make 15% margin on it. That's ridiculous. So it's not a very effective manufacturing model. The cottage model of many smaller makers with a smaller staff designing the niche products is far more cost effective. Back to the thing in my pocket, the phone. There are 5 big car makers, there are 20,000 models of phone.
That's true, but you can't design a complex product like a mobile phone with less than, you know, 200 or 300 extras.
Sure.
It's so complicated.
Sure.
I'm really struggling to,
Yeah.
it's a great idea what you're doing.
Yep.
It's fantastic, but I just can't see it.
Yeah.
You're going to produce a car, this time next year you'll have a car that's you can sort of put into production.
Mm-hmm.
Okay.
Yeah, our factory in Finland pushes through 100 million euros per year of product, and it has probably 40 active engineering and production staff to do that. It's all about the manufacturing model, because the computer systems now are so enabling that you can actually do quite a lot with very little. And yeah, because we've got the grace of lovely smart Finnish IT type people, yeah, we do really well, and that's why Normet's always worked in its niche. Be able to do what other people can't, because we don't need so many bums on seats.
What's the cost like between the Land Cruiser being mega expensive compared to what you're putting out?
Yep. We're mega expensive too.
Oh, yeah.
A Land Cruiser, because you buy a Land Cruiser for $60,000, by the time it gets to the mine it'll be anywhere from $80,000 to $120,000, and that'll last 2 years. Yep. So a Land Cruiser's costing you $60,000 a year just hosed up the wall in writing it down, because you're going to throw it away in a couple of years. So no, our vehicles, normally our vehicles last 10 years, but I know these things get a hard life. So we figure we can get economically 5 or 6 years out of a vehicle. We cost more, but we spread it across 3 times the life, so significantly less. Yeah, and I had some cost stuff there before. When you put a Land Cruiser in a mine, they're running about $40 per hour just on maintenance, not paying the wages, just the parts. $40 an hour for maintenance, $15 an hour for fuel, and about $15 an hour for writing off the cost of the vehicle. So you're $60 or $70 an hour for a Land Cruiser. It's high. So
I run the Aeva Facebook page.
Yeah.
I do the admin for that, and just the other day I put a post up. Local car maker aims to keep SA's automotive industry alive following Holt's departure. Melbourne-based Ethan Automotive
Yep.
is looking to open a head office at Port Adelaide as part of a broader plan to manufacture cars in South Australia.
Yeah, and that's one of the things we're trying to get across federally more than state, is because we're all cottage industries, because we've got the problem you point out in critical mass. You get lots of cottage guys far away, and we're not going to have the expertise to be able to walk across to the cafe and talk to someone who works somewhere else and solve a problem. So yeah, what we want to see is us plus the EV makers around the world, plus people like that want to make cars, all deliberately pulled in, whatever residual value we've got in the auto industry pulled into one place. Because that isn't going to solve all of our problems on efficiency, but I can see that if we're left scattered across the land, yeah, we'll have a few years of manufacturing and then it'll all just float off again to somewhere that's cheaper to make. But if they're doing that, that's something we really want to talk to the state government about as well. And we are doing that with the defence sector already, with defence manufacturing, to bring to their attention that we might make different products, but we have the same supply chain, we have the same problems.
Was that slide you put up earlier a list of local suppliers, or are they spread out?
Most of those, 2/3 of those are in the state. The remainder are in Victoria, and there's tritium from up in Brisbane was on that list. So yeah, a lot of them are all local. The biggest problem we have is there are good AC motor makers in Australia, not many, but they exist. They need volume to be able to get their businesses viable. That's the problem they've got. There's 2 good motor makers I know of that do really well on this, but they're not economically viable without orders. Without that, we'll end up going to an overseas maker. Tritium are brilliant, but they've got the same problem of just getting enough volume. They outclass every other control that I've assessed in that price range. But we got no batteries. Yeah. Sorry? Yeah. They don't understand the growth trajectory as much as anything, because if someone was coming to you in 1990 and says, do you want to be the dominant force in mobile phones in the next 20 years? You have the opportunity to have Nokia, Apple, Samsung on your doorstep. And you turn your back on that. You'd have to be crazy, right? But what we're trying to do is because we're not trying to build what China does, which is low cost cars, a $15,000 EV. We're only trying to build the things that are top end, premium, Rolls-Royce, high margin product with very rich businesses, the Apple end of the scale, the Apple margins. That's the only thing we're trying to retain here. That's the only thing I'm trying to build with this vehicle, is the best, because I know that's the most profitable business.
Why is it the normal vehicle is going to last a lot longer than the Land Cruiser?
Yeah, it's ruggedisation. We've been building vehicles for 50 years. We know every possible thing there is about metallurgy, materials, loads, the environment, to know what works and what doesn't. So by process of elimination, we've been there longer than Toyota has even. Because Toyota's been in the mine for 20 years, we've been there 30 years before them. And Toyota wasn't going to re-engineer their car to work in a mine, and we did. So it's simply just the 50 years of preceding trial and error that means that we build it right the first time.
Did you use local steel?
Yes. Local steel's great. No. Good. Actually, not. If you use steel, we use local steel because there's something special about that it doesn't rust. Overseas steel's terrible. Yeah, lots of stainless steel, lots of composites, special paints, and some other tricks.
Are those paints available to you, or do you make them yourself?
No, they're standard commercial paint, so we do have a chemical division, so we do make some of the stuff ourselves, but no, paint's not one of them.
And I'm wondering about the underground loop. How can that be implemented? How difficult is that?
Quite. That's what we're not doing that part. We know that University of Newcastle is doing that experiment this year. Standard commercial wireless high frequency charging hardware that they're using. That part's not difficult. Just need a lot of it. Yeah, well, you don't need it on all the roads, because on the mines it's just like a tree. You've got a main trunk and then all of the branches that spread out from it. So the main charging infrastructure only goes on the main trunk.
Is there a cost per kilometre for that stuff?
You're pretty high, I believe. It's about $1 million per kilometre, but
Maximum.
Digging the tunnel cost a bit more than that, so it's actually not that bad. Yeah, they pull more than $1 million per kilometre out of the ground in terms of the ore they dug out to make the hole, so it's actually not that bad.
Do you have any commonality with defence with their military vehicles?
A little bit. Again, their process is different, their custom is very different. But we do have a lot in common in terms of the scale of our manufacture. And when you asked about engineering, we don't need engineers much. We don't need a lot of engineer bums on seats because we make stuff nice and simple. Manufacturing in low volume is something else the state's done well. When we try to flip from where we are in design phase to manufacture is where we are currently developing that plan to be able to use all the experience that's come from some of the defence jobs that have come before.
Do you have access to all the robotics you need to build these things, or you don't need to do that?
Yeah, we do. Yeah, we use the robotics already on our assembly line. So robotic machining, robotic welding, it's a fairly routine little process because we just do learning robots for our welding and stuff. So you just show it once and it remembers.
That's what I thought the commonality between defence and yourselves might be just the access to the robotics.
Yep, and that's why we're trying to get everyone in the same place. It's really important to the success of this that apart from designing something that people can buy, knowing that if we put defence in the same place, I'll buy my parts for cheaper than if I was on my own.
Yeah, but are they doing electric vehicles as well in defence? They're probably not.
They do. They've explored it. There's a vehicle in Bendigo, which is a mine-protected vehicle that Thales is doing. It does have about a 40 kilowatt starter generator that can go in it. I don't believe they've enabled it as a true EV or plug-in electric vehicle. They use it more because they want to use it as a generator, so they're running radars and stuff, so they can use the diesel engine as a generator. But it does work the other way if they wanted it to. But the thing with defence is there's no domestically owned defence companies. It's British Aerospace, French Thales, etc. So there's no so design-wise, component-wise, those vendors, they're all from overseas, quite deliberately because the head offices of those companies are overseas, and they will be sourcing their parts from their domestic supply chains. That's something we're trying to avoid.
There was a company in Western Australia, possibly still is, called OKA, making four-wheel drives. Are they in the same sort of, I mean obviously they're still running petrol or diesel. Are they the sort of companies that you can link up with at all?
No, they've never really tailored them to mining. They do them they've used those vehicles for remote areas for when you're doing drill or exploration and stuff. Ockers have gone that way, but for all number of reasons, the Ockers can't go underground. They just don't work.
What do you hope to gain as far as the AEVA is concerned, Australia-wide? What do you hope to gain from this meeting, and do you want to gather together people that are in the industry who may be willing to say, all right, I'm prepared to work on a motor? Just networking, because we've got to build this lean. There's something that happens in some of the EV industries, and I'd say that it's, I've seen it in European builds, is because EVs can potentially be seen as a big kind of a halo product. They'll attract all kinds of subsidies, and so that there's infinite money available and infinite financing at 0.1% European interest rates. And because of the amount of cash involved, the hardware immediately becomes expensive. And the consultants are immediately on $200 an hour for a 6-month contract to tell you what colour spark plug it needs or something. It becomes very inefficient very fast. We deliberately need to avoid that. So I'm trying to look for a network of doers, people who have done it, that have built it, that are
that can help us in a very pragmatic way. So when we're looking at batteries, for example, we can go to Brucer and we can buy a battery. A good name. Brucer's got a good name. The European. And if you try to buy a Brucer battery, it's quite expensive because of that. Because of the way that nature works. They're currently used a lot in R&D vehicles. So when you buy, when you go buy a battery and Brucer says that'll be $120,000, people will pay it. Well, I'm not. And so we need pragmatic people that can point out that this is 98% as good as the fully tested compartmentalized EU certified batteries. And for what I'm doing, 98% is close enough. Okay, so yes, the network of prior experience. There's people in the room that have been building EVs since the 80s. Just bump us in the right direction, and it doesn't need to be the perfect vehicle first time. I'm new to this. A lot of people are new to this, but if we can demonstrate a functional vehicle that makes people happy the first time off, and just plant the seed of an idea, plant the seed of an industry, that's all we need. Plant it, let it grow enough roots that we start selling them, and from there then we can start to grow the input, the industry, the people that sell EVs that want to actually have jobs selling their expertise can then start to find places that they can work. But at the moment we're very, very small, and we need to recognise we're very small, so it's got to be the kind advice and the quiet word at the meeting. We'll get this off the ground. Start small. Small. I like small in the beginning. Sorry.
So the vehicle that you showed us up there, that your guys in Finland have engineered.
Well, my guys here, yes.
Sorry?
Yeah, it was all done here.
Oh, okay.
It's 100% Australian.
Okay. You're happy with that design as the vehicle which
Yep.
will best suit the needs of that, and so we're purely
Yep.
now in the drivetrain section of the development.
It satisfies the need the customer thinks they have, if you understand. They've been driving Land Cruisers for so long, they think they need a Land Cruiser. So that's the entry point that they're prepared to buy. It's not actually the best vehicle, and it actually wouldn't make the best EV, but we've got to start somewhere, right? We've got to start with something someone's prepared to spend their money on. So yeah, and I designed that vehicle, I knew I wanted an EV from day one. And I've actually designed something with an EV space claim and wedged a diesel engine into it. It's actually an optimized electric vehicle. It's like getting a Tesla and jamming a petrol engine in the front of it. It's not going to be a very pretty engine installation, and that's actually what I've got in that vehicle. Strange, but that's how it worked.
So when do you expect to have a prototype with a drivetrain and a battery actually moving?
Christmas. I need to demonstrate Christmas this year, yeah.
So how far are you along with that?
I've got a list of likely candidates. I've got 4 diesel vehicles, of which I'm going to destroy one and turn it into a plug-in EV. Hey?
If you build these things, why don't you just build one off the production without the motor and drivetrain?
Because we've got prototypes, we want to use them for multiple purposes, I suppose. They're easily re-rolled.
Since you pull the motor out, it's not a prototype, it's not a diesel. Like it's
Yeah.
being retrograde, like you're
It is a little bit, yes.
So why do that? Like why not have 3 diesels for people to look at or whatever, and have one that comes off the production line
Yeah.
with the department for the batteries?
Yeah, we can do that. Yeah, we can do that as well, because we've got a line, so it's just as easy for me to run a new one down.
That's going to happen before Christmas.
Yep,
So when's that
absolutely.
start? Like it's March now.
Yep. We're getting our supplier tenders back through April, May.
It's just to build one.
June, July, August is long lead time supply of parts. They're surprisingly fast to build a vehicle.
Yeah, but is it just to build one, or are you going to build
Yeah, one.
one?
Yeah, we need one so that we can show people what an EV is.
If you want to,
Because at the moment there's no understanding or appreciation as to how an EV is even used in a tunnel. It's a completely foreign concept.
but as far as the supplies are concerned, you're just looking to buy one set of batteries, one motor.
Yeah, it's pretty inefficient. No, it's not. Well, It's not hard, but it's also fairly inefficient because we're buying one.
Well, that's
If I was buying 300 for a bus fleet, it's actually somewhat easier.
yeah, but next time.
Ones suck.
So where's the car? Where's it sitting?
At our workshop in Torrensville.
Torrance? You going to give us the address?
Let's show and tell.
Like, you know,
When show and tell is probably sometime around October.
there's a whole lot of brains here that like to go and have a look, and you can get there with your notepad and take notes.
Yeah, we'll have to organise a field trip. Yep.
Coming back to the Toyota.
Yep, we can organise a field trip to get some people to look at it and give us some ideas.
The Toyota, as you say, was not developed for the mines and therefore
Yep.
it's unsuitable.
Yep.
What is it about the Toyotas which is actually failing? Obviously there's bodies rusting out. What about the mechanically? and
Yeah.
the-
Yeah. Most of the $40 in maintenance cost goes to drivetrain. So axles that fail, universal joints in particular in the axles that come apart, diesel engines that, they're a V8 diesel. Well, all the mud and water and filth sits in the top of the V and just destroys everything in the top of that engine. The sump rusts out, so the oil comes out, and that tends to stop them. Sorry? Yeah, they're always going up and down hills, they're always at an angle, so the lubrication doesn't work. Because even though they're four-wheel drives, they're not intended to drive up and down the Himalayas on a constant basis. So yeah, it's the stuff related to the yeah.
Because obviously if you could use the diff or parts of the vehicle,
Yeah.
that would give you a
Yeah.
leg up
Yeah.
in your prototype.
And things wear out anyway, but the difference in EV architecture is that things come in nice big simple blocks. So if you did have failure of a motor, then it just comes out as a nice elegant little block, where if you do a diesel engine in a Land Cruiser, it'll be some kind of little part that's up inside the engine. You've got to dismantle 500 other components off to get to it. An AC motor is a rotor, a stator and two bearings. Fairly easy to crack them.
Is there any problem with explosive gases and electric motors at all?
No, we're only in hard rock mines. We're starting, Normet's only ever done mining gold, copper, stuff like that, so there's no explosive gas for us to deal with. But with that said, it's a lot easier to make electric motors safe in a gas environment than it is for an internal combustion engine.
Yeah, fair.
With the prototype, what size battery pack are you trying to build with that? Is that to allow like the 3-hour runtime, or how much?
Yeah. Well, we don't know how much people actually need. That's the funny thing, is we don't know how much we actually use because no one's ever built one, run one and worked it out. No, we're going for about 50 kilowatt hour because we know that fully loaded vehicle, the constant power output is 50 kilowatts, so it's a 1C discharge from the battery. It's just an abstract guess that 1C is not going to hurt a battery, so we'll make it 50 kilowatt hour.
The question is, how much do you think having that charging will allow you to reduce the battery pack size and battery cost?
Oh, heaps. A lot.
How are you working that out?
Yeah, regen on a vehicle going down a hill means that we will actually be able to save quite a lot.
It doesn't help you going downhill at the start of the day. Then.
Yeah, well, that's just a matter of training. The second day they drive it, we'll tell them we didn't need to charge it up the day we started. That's the fun thing about this. The entire concept is novel, it's interesting for people. There's lots of learning involved in it. We're going to build a vehicle, put a data logger on it, record every watt that goes in, every watt that goes out, and work out where all the energy's going in a mine. Because no one can tell us. There's no, like when you do a car, when you estimate the range, the mile per gallon equivalent, there's a standard test for that, right? You put it on a dyno and it's got a simulated test that says your car gets 33 miles per gallon. But that's not relevant to a mine because the duty cycle is completely wrong. But we know that we can model it, and we are doing modelling quite well through. We're lucky enough to get some associations with some people that work on electric race cars and stuff like that. They're very good at modelling the energy in and energy out. So we actually have looked very closely at how much we need. 50 kilowatt hours potentially is a lot in this environment.
What time frame, what run time would that be?
Well, potentially we only, even though it's a 4-ton vehicle, we might only be averaging about 12 kilowatt hours average. So we could get 4 and a bit hours out of it, which is all right for a 4-ton vehicle. Sorry.
You're working with like a lead customer locally, so that you're building what the customer actually wants?
Yeah, we do.
Yes.
Yep. We always work with, well, not Rio Tinto anymore, they're Glencore, which is a Swiss company, and BHP. They're both really good, really proactive with adopting new technology, and really good at their specifications as well for the knowing what they need to do their job. So both really good customers. And the thing is that Australia's always been the go-to place for any new technology. The thing about doing it in Australia is that if any new mining process, any new mining machine was ever going to be used in the last 20 or 30 years, it's largely been done in Australia. They test it here, prove that it works here, and then they'll adopt it overseas. Because we're a good little bit, it's not that we're better or worse, we're a great benchmark. So if EVs are going to be commercialised to be used in mines, they'll be developed in Australia, and I can give you a really good confirmation of that, is that when General Electric, I said, are developing EVs. They bought a company in Newcastle a few years ago. The sole purpose of that appears to be that they want to take the Australian and Chinese vehicle market. They took the engineers away to their American division, informed them of how their traction systems work in electric drives. Those engineers are now apparently, very secretly, working on a battery electric coal mining vehicle in Newcastle, and General Electric will design it in Newcastle and Brisbane. They will test it in Newcastle and Brisbane. It'll be rolled out across Australia, it'll be proved to work, and then it'll be taken to coal mines globally. It's just a system that really works well because we come up with good novel answers in Australia. So, yeah, I'm really hoping it works. There's a lot that can go wrong, but the reason I wanted to try to present it to everyone was to try to explain what we're doing so that we can come up with the best possible first generation system, make it commercially successful, and give some people some jobs. Sorry?
Just a quick one. You said it was HF charging. What frequency?
I have no idea about the charging technology, sorry. Yeah, when we started talking about the charging systems, we've actually deferred to the university and the supplier, and what they'll do is supply us a system more or less as a black box. They give us an interface and just say, it bolts here. Yep. Yeah, no, it's not too bad, and we also shield them as well. There's metal belly plates, so the EM exposures are quite low. The charging system's actually on the remote ends of the vehicle as well, so the cabin we put in the middle, and so the charge systems sit out on the extreme ends on the bumpers. Yeah, for a couple of reasons. One is it's far from the people, but also we've got the advantage of being in tunnels. So a lot of the charge systems don't always go in the floor, but against the wall. So you just drive your charger into the wall and run into the charger, and it gives a really close charge coupling. This is one of the ways we modelled the system layout. Okay.
Are you putting in all the mod cons for them? Because I know that's one thing, air conditioning, that they'll want down there, otherwise that's not right.
Yeah, we hear a lot about air conditioning, and I'm a little bit old school, and think that people could possibly need to harden up a little.
Yeah.
Yeah. No, one of the reasons it's hot is because the diesel engine's in the mine. That's the main reason it's hot in most mines. Like Mount Isa, it's 2 and a bit kilometres deep, so the rocks are hot. That's a unique example. But if you can remove basically about 5 megawatts of heat generation from the mine, you'll find that the mine's own air conditioning system and its vent system will be able to keep up. It just can't keep up with the diesel engine, where you burn a litre of diesel, you put basically 100% of that is turned into heat at some point. It propels you forward, but that's going to turn into heat anyway as soon as you hit the brakes.
Electric motors get hot.
Yeah, you do, but in terms of the overall efficiency of the system, yeah, it's 80% less overall energy. It's only to move you forward. Yeah, so we are not fitting air conditioners because that's just a way to... We just don't have the power density in batteries yet. Like I said, it's not the system for everyone. There'll be diesel vehicles in mines for a little while, and someone that needs air conditioning is one of those candidates. But almost everyone else, when you get a mine and actually it goes into shutdown or something and they just leave the fans running and the vehicles aren't going, I measured the difference in temperature and it's significant. So yeah, I think they'll find that they don't actually need a lot of the mod cons that they've come to expect. And that's great because it builds a more simple, more reliable vehicle anyway. And eventually batteries will get better and we'll give them an air conditioner back. Okay.
Are we all done? Yep. Well, I'd like to thank you very much indeed for a very interesting talk indeed. I think that the thing that I get the feeling is we want show and tell. So
sure.
So yeah, I think that we'd like to see the pudding in the flesh.
Would
If that's
like
a mixed
people.
metaphor.
Yeah, and that's the purpose of this, is because I can see we need to get people involved.
I think there would be some suggestions
so that the good ideas float to the surface.
Do something or other. Well, a lot of those questions might be answered by, well, because we do it better another way, but there's always the chance that somebody will say, oh, well, you could do that. And you think, yeah, that's it. That's exactly what we could do.
Yeah, that's exactly the dilemma we have.
There's some smart people in this room. Don't look at me, but there are some very clever people here, and you know, use them.
Okay. Yeah, I'll call or email and we'll see if we can find some mechanism to get people through, because I just want to avoid a casual stroll through our workshops and in Torrensville if we can avoid it, but it seems to be done in a controlled fashion.
Yeah. Well, look, thank you very, very much indeed.
Thank you.